we do first? What you got?
Put in y for m.
Put in y for m. Yep. For m of x. So y is going to equal 17 x to the 5th power minus 84. Love it. Then what? Switch my x and my y. So I get x then is equal to 17 y to the 5th minus 84. Now what? Add 84 to both sides. X plus 84 equals 17 y to the 5th power. Divided by 17. Scroll down just a little bit. X plus 84 over 17 equals y to the 5th power. Take the 5th root. Then what?
Put the opposite, or the inverse of f of x. Is that what you said?
But it's not f.
Oh, m of x.
So m to the negative 1 of x equals
that.
that.
Like a set.
The inverse of m.
Okay.
Yeah, buddy? What's up?
What if on your homework you didn't do the to the negative 1?
Then you're wrong. Just so you know. Yeah. Because if you put it back in the function notation, then you're saying that those two functions are the same. And they're not. Okay?
I didn't know.
Oh, you didn't do it? And so we know we did it wrong? Alright, yeah. And then no. Okay? So, play a game. There's 2 rules to this game. Okay? The game is called function, not a function. Okay? There's 2 rules. One rule you already know. Okay? How do I tell if what I'm looking at is or is not a function? Vertical line test. Yep. Okay? So I am going to use the vertical line test to determine if the function that I'm looking at is or is not a function. Okay? Remember, it can only touch the graph in one spot, the vertical line. It can only touch in one spot. If that's the case, we got ourselves a function. Okay? Rule number 2 says that I am going to use something called the horizontal line test, and that is going to determine if the inverse of what I'm looking at is or is not a function. Same rule applies. It can only touch the horizontal line once. Okay. Now, this brings up options. Okay. Option number 1 is that what I'm looking at could or could not be a function. Option number 2 is the inverse of what I'm looking at could or could not be a function. So I could have it where both are functions. What I'm looking at and the inverse are a function. I could have it where what I'm looking at is a function, but the inverse is not a function. I could have it where what I'm looking at is not a function, but the inverse is a function. And I can have it where what I'm looking at is not a function, and the inverse is not a function. Okay, so there's 4 different possible things that we could do in this wonderful function, not a function game. Now, most importantly, is if the function or I should say that in a different way. If the graph passes both tests, we call that function one-to-one. NTC, for many years, has had a question on their final that says, determine if this function is one-to-one. If so, find the inverse. Okay? So what you need to do then is you need to draw a quick sketch of that function. Run it through the vertical line test, run it through the horizontal line test. If it passes both, boom, it's one-to-one. And then you can find the inverse. Okay? For purposes of today, we are going to be sketching functions. Okay? So, my first function is 2x squared. What should that graph look like?
It should,
Let's train it up. What should that graph look like? You've done it a lot, actually. So it should be, so what kind of a shape is that? That's a U? So with an opening going up? Okay. Because why? Because the 2 is positive. So it should look like that, right? Yeah? Okay. In fact, it does. Okay. My first question is f of x, which is my red function in there, is that, let me get a vertical line. Actually, probably could go a little thinner than that. Okay. Is that a function? Yep. Is the inverse of this a function?
No.
Why not?
Because it doesn't pass horizontal lines.
Touches twice. Is f of x equals 2x squared a one-to-one function?
No.
Nope, it's not. Not a function. Or it's not one-to-one. It is a function. Its inverse is not a function. And it is. Okay? So, what I would like you to do is, let's go straight up NTC on this bad boy. Okay? Okay? So, sketch it. Determine if it is a function. Determine if the inverse is a function. And then find the inverse if it is. If it's one-to-one, find the inverse. Agree with the picture. Cubic needs to be going in opposite directions. Positive lead coefficient means we're going to be ending up and to the right. Okay? No linear term, so no hump inside the cubic. If there were a quadratic and a linear term, then there would be a pronounced hump in there. There isn't one in this case, so it's just a flattening and then a changing of the guard. Is f of x a function? Is what I'm looking at a function? Yep. Passes the vertical line test. Is what I'm looking at's inverse a function? Why?
Because like if you did the test, each point would only, I mean,
I'm listening.
there would only be 1 point hitting the line in each time. I just can't talk.
The tricky part is like right in there, right?
Right.
But really, it never goes flat. It just we got to
Just
zoom in a little bit. Yeah. So yeah, so it passes the horizontal line test. So this would be a yes on that one. So f of x equals x cubed minus 2. We need to find, because it's both, now it's 1-to-1. We need to find the inverse, correct? So this would become y equals x cubed minus 2. Flippity floppity. Add 2. Cube root. Let me get that. Same thing. Sketch it. Function, not a function. Inverse function, not a function. If it's 1 to 1, find me the inverse. Okay. What's this one going to look like? It's going to look like a V. Opening up or opening down? Opening up. Is it a function? Passes the vertical line test, right? Is the inverse a function? No. Fails the horizontal line test. So is this function 1 to 1? No. So I don't need to find the inverse because the function's not 1 to 1. Okay? Today you're going to get 2 worksheets. The first worksheet that I'm going to hand out is going to be the worksheet to go along with today's stuff. Okay? The second worksheet that I am going to hand out is review for Monday's test. Quest. What? Both due on Monday. Yep. Okay. So on Monday, we will be taking a test in class all about radicals and inverses.